Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Najmuddin Albiotman. So today I'm going to talk about multi-channel optoelectronic measurement system for soil nutrients analysis. Okay, now let's start with the introduction. Okay, to address the issue that arise when farmer abuse chemical fertilizer, quick and effective portable testing instrument for the detection and quantification of nitrogen, phosphorus, and potassium in soil are required. The usage of currently available portable instrument, which only have a few channels, notably measurement and different channels, present challenge. We present a home-built multi-channel optoelectronics measuring system that which automatically switching the light source for detecting N, P, and K level in soil sample. With the sensor, we also can, without doubt, uh, quickly monitoring and analyze of soil nutrient that may lead to more effective fertilizer application and as a result, higher crop output. Chemical fertilizer use that is efficient also help to keep the environment clean. Okay, now let's talk about principal design for optoelectronic system. Okay, the principal design is the LED driver circuit produce the current pulse for each LED as long as the electric power supply is switched on. Okay, the lights go through the square spectrophotometer cells directly and sequentially, and after achieving the desired measurement result of the NPK concentration, the power supply of the LED switch are off. The power the power supply to the LED is controlled by the MCU to reach the desired level automatically. The photodiode 2CR1227 then measure the transmit light from the spectrophotometer cell, followed by the application of the signal by the TLC2654 amplifier. The digital conversion are depend on the output of the amplifier. The microcontroller unit PIC24FJ64 offers multiply communication interface, including the universal asynchronous receiver transmitter UART and serial peripheral interface SPI and integrated circuit I2C, an integrated touchscreen control that drive the relative height solution LCD also provided by this MCU chip. Okay, for the construction of the optoelectronic measurement system, the circuit of the multi-channel optoelectronic measurement system. A. The diagram of the constant current source circuit with a 3-terminal adjustable shunt regulator for driving LED. The front end circuit of an impedance amplifier for the photodiode and the responding output voltage of the circuit display on the oscilloscope. Okay, as you can see in the picture, the B, the prototype of the microcontroller unit MCU circuit board including a chip of PIC24FJ64, a 60-bit A/D converter ADS 1100 and a multiply switcher CD4051. Okay, the construction of the optoelectronic measurement system. Okay, the first one is the multi-sample cell was explored in this optoelectronic measurement system and consists of joint LED light source having peak emission wavelength of 405 nm, 360 nm, and 515 nm, and photodiode firmly fits on the supporting clamp. However, due to the special chromatic non-uniformity in LED lightning source and photodiodes, the consistency of the measurement result should be calibrated prior to the measurement the concentration of the soil nutrient. Okay, from the picture, the resulting optoelectronic measurement system after assembly appropriately the seat joint LED converter holder with seat cell and also seat photodiode an electric board with a microcontroller and also the amplifier and the converter is shown diagrammatically in figure A and photographically in figure B. Okay, for the material and method, for this technology is soil. The first one is soil sample collection and preparation. Okay, to confirm the characteristic of the optoelectronic measurement system, the soil was randomly sampled at a sampling depth of 20 cm from a wheat field. Okay, these samples were taken at a sample position indicated by a different GPS. Okay, the soil was okay. The next one is the soil was the calcareous type that has elevated level of both magnesium carbonate and calcium. The disintegrated granules were sieved with a mesh of size of 1 millimeter to remove the undisintegrated granules prior to the experiment. A mass of 5 grams of dry soil sample was measured with an accuracy of 0.01 gram and then placed into a 100 milliliter triangle bottle and thereafter mixed with 50 milliliter universal extraction solution. This sample solution stir was stirred for 30 minutes with a constant speed of 180 rpm. Okay. Lastly, after stirring any undissolved granule, were removed by filterization. The filter was then placed into another 100 milliliter triangle bottle for further experiment. Okay, the next one is measurement principle. The ob the observation spectra of the neutral solution obtained using the optoelectronic measurement system show concentration of nitrogen, potassium, and also phosphorus in the soil sample. The conventional lab-based method include Nash colorimetry method for measuring nitrogen, also method for the determination of available phosphorus in calcareous soil for measuring phosphorus, and flame photometer for measuring potassium, respectively. Okay, to account for the light attenuation caused by the square spectrum photometer cells, a blend solution without any lights of interest is measured prior to commencement of the experiment. The standardized transmission spectra of a measured solution was calculated as the ratio of the flux transmitted by the measured solution to that transmitted by the solution of known concentration under identical illumination condition. Okay, the next one is the result. In order to evaluate the performance of this measurement system, firstly known as concentration of potassium, phosphorus, and nitrogen, were arranged to be sequentially measured to establish the measurement model prior to the sample measurement. The maximum relative standard deviation in the observant were 5.24%, 5.64%, and also 5.990% for NP and K measurement with the three repetition respectively. The relation between concentration of N, P, and K and their corresponding absorbance value is displayed. From this result, it was observed that there exists a linear relationship between absorbance and concentration of the sample, uh, as expected from the Lambert law. Okay, as you can see in the picture, the sensitive change observable per chain of analytic concentration of the optoelectronic device was found to be 7.17, 5.96, and also 1.41 for NP and K measurement respectively. Okay, in conclusion, in this study, we show how an optoelectronic measurement system based on joint LED light source and also a multi-channel converter holder may be utilized to quickly and easily quantify the concentration of N, P, and K. The concentration of measured solution follow the Beer-Lambert rule, which is explained along with the observable composition. Prior to the practical measurement of soil sample, composition was used to justify the observation across multiple channels to ensure the system measurement accuracy. The observation was then assumed to fluctuate linearly with N, P, and K value in the measurement range. All channels has had cumulative relative standard deviation of observation of 12.22%, 127%, and 1% respectively. Based on the result, this multi-channel measurement system was was developed in-house to measure soil nutrient, providing a reliable and robust method for portable and rapid measurement of soil nutrient. It also provides capability for more effective, continuous, and site-specific nutrient measurement for use identification of the correct fertilizer for use in farm. In addition, this multi-channel measurement system and the optoelectronic measurement method can be further applied for the detection of pesticide and heavy metal as well as other related applications involving biometrics. Thank you.